In this special edition Elektor Engineering Insights, I'm going to be asking 3 questions of Moshik Rubin to find out how Cadence supports design verification of those advanced and powerful SoCs that go into our smartphones.
Right, well, it's a long and complex process. It really starts with the architecture definition. You need to define what is it that you need to achieve, and then what are going to be the main components of your chips. Once you have that, you are starting to write the logic to implement it, right? You call it kind of RTA level, this transition level. Yeah. And once you have that, you are starting to simulate it and see that actually it works as you expected, and then you're fine-tuning, fixing bugs that you find, etc. And once you are good with that, you're starting with the process to translate it into something that can go to the physical implementation, which is the actual what you call synthesis. You are taking a high-level definition and translate it into the actual transistors and gates that eventually being going to send to the fab and being manufactured as a chip. So that's kind of in a very kind of, in a nutshell, the process of chip design.
Now your specialization area is in the verification process. So what is the verification process in chip design?
Right, so indeed, the verification process is actually one of the biggest time-consuming and effort-consuming part of the chip design, because once that you have the logic and you have it well defined, now you need to test it and ensure that it works in all different scenarios out there, right? So think about, a chip for your phone. How many different scenarios you need to handle, right? You want to watch the video, you want to make a phone call, you want to get, the different application working in parallel, and one is kind of crossing with another. There are endless scenarios. So just to verify and make sure that it's going to work as you expected, it's a huge task, and that's the verification phase.
Now, in that verification phase, obviously, there are complex interfaces. Let's take something like USB, for example.
Right.
The long strings of data, and that would take a very, very long time to verify in that process. Are there approaches that you use to sort of simplify that still gives you the coverage, but doesn't take hours and hours to test one byte of data being transferred?
Exactly. So, things that are happening at milliseconds or second in real life, if you want to simulate it, before you have the actual silicon and chip, it could take weeks of simulation time. So we actually, for that, we have different verification engines, we call it, different kind of machines that can be used to simulate your chip. So we have a simulator that runs on your PC, and that gives you a very comprehensive simulation, and every cycle you can see what is happening. But of course, that is limited in time and capacity, right? Again, if you want to emulate sticking USB and waiting to all the kind of enumeration process, you probably need to sit like 2 days and stare at your PC. So for that, we have emulation boxes. So it's kind of hardware boxes that all they do, they are taking your design and run it on a real hardware, and then you get dramatically faster performance, but less visibility into each part of the process. So, so it's a trade-off. We have multiple different tools. All of them are in order to enable you to do the best verification you can in the different kind of trade-offs that we provide you.
Now you said here that you sit there in front of your PC and run these tests, but I imagine with a multi-core SoC and a wireless interface and wired interfaces and memory interfaces, these simulations aren't actually executed on a PC. There must be some sort of cloud support, I assume, for these types of efforts.
Right. So our customers are actually, they are having dedicated server farms to run all the simulation in an efficient way, because again, you are not running just one scenario at a time, right? Again, we were talking about hundreds and thousands of different scenarios that you want to test. So our customers are actually having this farm and running in parallel multiple tests that run and trying to get all the different combination, or at least those that are common, because if you just think about it, the number of combinations is infinite. There's no way to test everything. So our customers are actually thinking what is the subset that we must focus on, and even that, we're talking about thousands of different simulations. So we said that verification is the biggest chunk of the whole kind of design process, and within verification, debug is the biggest time-consuming task. And the reason is that, think about your smartphone. Again, right, there are so many pieces there, right? Multiple IPs, you described the USB and the different, cores and the camera and the memory. And once, our customers, they are running their hundreds and thousands of different tests, and they're coming in the morning, and then they're seeing some failures. So now they need to sit together and understand, okay, out of all this failure, first, which one we are tackling first and which one is less important. Now, once they decide on that, they need to start digging and understand what is the source of this failure, where is it coming from? And if it's coming from some IP that they bought from another companies, they need to pick up the phone and talk with them. And then, once they did understand where it's coming from, they need to narrow it down to the very specific root cause of this particular error, and then they go and fix it. But actually the fix part is the easiest part, but until you get to know what has changed at making you the failure, there's a huge process that takes many people and a lot of time.
So it sounds to me like the tools are one part of it. They can tell you that an error has occurred, but they can't tell you why the error has occurred, and there's a big reliance on experience and an intuition maybe from the team as well to figure all that out.
Exactly. So, we at Cadence, we were focusing for many years on making the tool faster, with bigger capacity, because again, the design are getting bigger and you need to be able to simulate everything much faster. But all the process of figuring out where is the bug, how to narrow it down, how to fix it, it really still relies on the engineering expertise, right? They need to look at the failure, scratch their head and say, oh, I think it's coming from that particular model that last week I made a change, it might be related to that. Or again, they need to call their friends and brainstorm together. So it's really manual process, and again, time consuming as it was done up until today. This is exactly the direction, and that's very much related to the solution we just announced. There is tons of data. There's tons of data because every simulation that our customers run, there's waveform, there is log files, there is the design data itself that is coming out of it, and all those runs are running in parallel. So the data is there, and up until now, no one was picking it up and doing something useful with it. So now, with our new solution that it's being called Verisium, that's exactly what we are doing. We're actually having all our different engines, if it's a simulation or the emulation box that I mentioned, all the different tools are now dumping the data in an intelligent way to a unified database. And you can look at it as kind of a big data lake that is being collected from everyone, not everyone, but also from the day before and the week before. And out of all this data, we can, utilizing AI, we can do very similar process like we just mentioned about the engineers that is scratching his head, say, hey, 2 weeks ago, I made this change, it might be that, all of that we can do automatically and get very close, jumpstart the debug process for our customers.
So what sort of data is the AI of Verisium drawing upon? What sort of triggers and mechanisms are in place for finding out and highlighting where the problem might be?
Well, so we have several aspects of AI, different AI applications that we are applying in order to understand that. So, for example, we have an application called Pin Down that actually keeping track of all the changes that our customer made. So every time they are making a file change and they are checking it in, we keep this information aside. And not only that, we are keeping the information of which engineer, at which time, which file was changed, etc., etc. So when there is an error, when there is a failure, we can go back and based on AI model that we train, we can tell our customers, hey, the most likely change in the version of the file that caused this bug is probably this file that was checked 2 weeks ago in this file system. And not only that, we can go and revert this check automatically and rerun the regression and tell you that it now works. So we say, hey, with very high probability, this is the change that you made that caused the issue.
Yeah, smashing. So who's using Verisium today in the silicon development world?
So we have actually several customers that work with us early to qualify and partner with us until we get to the place that we can release it. And we just announced a solution called Verisium, and customers like Samsung, MediaTek, and ST were all part of this development. And they use different parts. Again, we have a series of different apps. I mentioned pin down. We also have different apps that can actually compare to waveform. Again, waveform is how the signal is kind of behaving in a very specific design, right? So imagine that you have a bug, and now you want to compare it to the version that you had yesterday that worked, and say why this one is working and this one doesn't. We can automatically, based on kind of AI model, we can compare it in an intelligent way and point you to the specific time and specific wave, specific signal that is most likely to cause the bug, and actually bring it up in the GUI side by side, that you see this change. That's probably where the bug is. So that's, again, part of our customers utilize this. Some of the other use kind of the file system, and we have additional applications that customers use and provide us kind of the feedback that the whole process can provide up until 10x productivity altogether in the debug process as part of verification tasks.
Well, thanks ever so much for that explanation. I think the development of SoCs is fascinating. We're seeing the power and performance of them in the smartphone market, but to then understand how something that uses AI very frequently is actually developed and supported with AI is a great insight.
Sure, thank you. And I really believe that it's kind of a paradigm shift in the way people are designing chip and doing verification, and it's about time to apply AI into this world as well. So thanks for the opportunity to talk with you.
Thank you.
Sure.
So that's all we have time for on this Elektor Engineering Insights. If you'd like to stay up to date on the trends in the electronics and semiconductor industry, click subscribe, and while you're there, give this video a like. And if you've got a topic you'd like to discuss, reach out to me, Stuart, on LinkedIn. See you next time.